question under square root 1 plus sin a by 1 minus sin a, which is equals to secant a plus tan a. So I will prove this one by taking left hand side, which is equals to under square root 1 plus sin a divided by 1 minus sin a. Here we know, if anyway we see an irrational number, we must and should rationalize the denominator. If anyway we see some irrational number in the denominator, we must and should rationalize that denominator. Here also we will follow the same method by taking exactly opposite symbol, 1 plus sin a by 1 plus sin a. Here the symbol is minus, that's why I am taking here plus. If the symbol is plus, here I will take minus. If I calculate this one, I will get 1 plus sin a divided 1 plus sin a whole square divided by, I can take here a minus b into a plus b, which is a square minus b square, 1 minus sin square a. All this will come under square root. And I have one identity which is sin square a plus cos square a, which is equals to 1. From this I can write cos square a, which is equals to 1 minus sin square a, so that here I can write 1 plus sin a whole square divided by, instead of this 1 minus sin square a, I can write cos square a. All this will come under square root symbol. If I split the square root for both numerator and denominator, 1 plus, or else here we can write like this, sin a divided by cos a whole square, and we can cancel these two things, and I will get here 1 plus sin a by cos a. Okay, then we can continue by splitting the fraction. 1 by cos a plus sin a by cos a. 1 by cos a is secant a and sin a by cos a is tan a. That is our RHS, right hand side, whatever they asked in the question. So what we can write? Hence LHS equals to RHS. We can write like this, NHS equals to RHS. Let us move to next question. Yes, this question also they have repeated many times in the board exam for 2 mark and 3 mark. Let us take left hand side here. Left hand side, what they gave in the question? Sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. Now from the numerator both terms I can take out sin theta common. In the first term I will be left with 1 minus 2 sin square theta. Why? Because sin theta into 1 is sin theta into minus 2 sin square theta is minus 2 sin cube theta divided by, from the denominator I can take out cos theta, then only I will get this tan theta. Sin theta by cos theta is tan theta, that is why I am taking out the cos theta. So here I will be left with 2 cos square theta minus, I took out the cos theta, the remaining factor will be 1. Now we can say sin theta by cos theta is sin theta divided by cos theta is tan theta, and we will modify and eradicate this one. We will modify and cancel this value. 1 minus 2 into sin square theta we can write as 1 minus cos square theta. All this will come under square root divided by 2 cos square theta minus 1. Now this tan theta as it is we can write, and 1 minus, send this minus 2 inside, minus 2 into 1 is minus 2, minus 2 into minus cos square theta is plus 2 cos square theta divided by 2 cos square theta minus 1. So here we can write tan theta as it is, and 1 minus 2 is 1, 1 minus 2 is minus 1, plus 2 cos square theta as it is will come divided by 2 cos square theta minus 1. Now we can cancel here these two. Why? Because those two are same factors, and finally I will be left with tan theta, which is right hand side of the question. Hence I can write here left hand side is equals to right hand side. Yes, okay. And what's our next question? Yes, very easy question, very interesting also. Let me take here color blue. So if we observe sin a plus cosecant a whole square plus cos a plus secant a whole square, which is equals to 7 plus tan square a plus cot square a. Let me take here left hand side, which is sin a plus cosecant a whole square plus cos a plus secant a whole square. This is my left hand side, and I can apply here a plus b whole square for both terms. Then I will get here, that is sin square a, I will get sin square a plus cosecant square a plus 2 into sin a into cosecant a. For this one also apply a plus b whole square. I will be getting here cos square a plus secant square a plus 2 cos a into secant a, and here I can say sin square a plus cos square a is 1. Then you see sin a into cos a, cosecant a will be cancelled, cos a into secant a will be cancelled. Why? Because sin a is equals to 1 by cosecant a, sin a is equals to 1 by cosecant a, cos a is equals to 1 by secant a, and if you send this secant a this side, you will get cos a into secant a, which is equals to 1. Instead of cos a into secant a, we can write 1. Instead of sin a into cosecant a, we can write 1. So here I'm 2 plus 2, I'm writing this one and this one, and what I am left with cosecant square a, here this one secant square a. 1 plus 2 plus 2, I'll get 5 plus here cosecant square a is equals to 1 plus tan square a, sorry 1 plus cot square a, and secant square a is equals to 1 plus tan square a. We have two identities, basic identities. From that I can write cosecant square a is 1 plus cot square a plus secant square a is 1 plus tan square a, so that we can write finally 5 plus 1 plus 1, which is 7, plus tan square a plus cot square a, and this is our right hand side of the question. So we can say hence left hand side is equals to right hand side, which is 4. That's it. Yes, let me take another question. Cosecant A minus sin A into secant A minus cos A, which is equals to 1 by tan A plus cot A. Yes, they are saying here separately you can solve left hand side and right hand side. Let us take left hand side first of all. Left hand side, they gave cosecant A minus sin A into secant A minus cos A. So here what I can write, cosecant I know 1 by sin A minus sin A as this will come into secant is we know 1 by cos A minus cos A as this will come. By taking LCM I will get 1 minus sin square A. LCM is nothing but just cross multiplying. 1 into 1 is 1, sin A into sin A is sin square A, sin A into 1 is sin A. Here also same procedure, 1 minus cos square A divided by cos A. Okay, we have a basic identity, sin square A plus cos square A, which is equals to 1. From this we can write cos square A, which is equals to 1 minus sin square A, and sin square A, which is equals to 1 minus cos square A. Here we have 1 minus sin square A, 1 minus cos square A. So instead of that 1 minus sin square A, we can write cos square A by sin A into sin square A by cos A, and I can cancel here sin A and the square, cos A and the square. I will be left with cos A into sin A. One second, let me remove that cos A into sin A. Now we came to one conclusion for the left hand side. Further we cannot reduce this one, and let us take now right hand side. Let us take right hand side. Right hand side is 1 by tan A plus cot A. Actually tan we can write as sin by cos, which is sin A by cos A, and cot A we can write as cos A by sin A. So by taking LCM we will get here 1 divided by sin square A plus cos square A all divided by sin A into cos A. Now by flipping the fraction we will get sin A into cos A divided by 1. Why I wrote 1? It is very important. We have the basic property sin square A plus cos square A is equals to 1. So here by comparing these two, we can say left hand side is equals to right hand side. And let us move to next question. Yes, we have one more question here, question number 10. Very easy question, very important also. Okay, let us take here left hand side. We have three parts here, part 1, part 2, part 3, and we'll prove these two, then finally we can write the entire statement. Let us take left hand side of part 1, 1 plus tan square A divided by 1 plus cot square A. the basic property. What are the basic properties? Secant square a is equals to 1 plus tan square a. Cosecant square a is equals to 1 plus cot square a. By using these two properties, in the numerator we can write secant square a, and in the denominator we can write cosecant square a. Cosecant square a, and secant square again we can write as 1 by cos square a divided by cosecant square we can write as 1 by sin square a. So if we flip the fraction, 1 by cos square a into sin square a by 1. Now sin square a by cos square a is tan square a, so which is this one. Now let us move to second thing. 1 minus tan a by 1 minus cot a whole square they gave now. Yes, now we can write here, we can write here 1 minus sin a by cos a whole divided by 1 minus cos a by sin a whole square. By taking LCM we can get here cos a minus sin a divided by cos a whole divided by sin a minus cos a divided by, here we will get sin a. All this will come inside the bracket. So this thing we can write as cos a minus sin a by cos a into sin a divided by sin a minus cos a. All this will come in square, which is equals to, actually here what we can write, that is very important, cos a minus sin a minus cos a. What if we multiply both numerator and denominator, and anyhow we can write here sin a by cos a, which is equals to tan a. What I will do, I will multiply and numerator and denominator with minus 1. So if I multiply the numerator with minus, I will get like this. Then cos a minus sin a as it is will come. If I multiply the denominator also with minus, I will get here cos a minus sin a whole square will come. Actually these two will be cancelled here. Then finally minus tan a whole square, which is actually tan square a. By splitting the square for this minus and tan, we will get like this. So final statement, what we can write here, final statement what we can write, we can write here final statement. We took first this thing and we proved tan square a, second thing we took and we proved tan square a. So we can write here finally 1 plus tan square a by 1 plus cot square a, which is equals to 1 minus tan a by 1 minus cot a whole square, which is equals to tan square a. That's it. Okay children, bye.